Hello students, our first unit is Introduction to Big Data and Hadoop. Today in this video we will be covering the Hadoop ecosystem. Now Hadoop ecosystem has consists of different components. The two major components are HDFS and MapReduce, and other components are HBase, Hive, Peak, Impala, Scoop, Flume, Zookeeper and Hue. This is the diagram for Hadoop ecosystem. You can see the different components of Hadoop ecosystem are categorized into 4 categories according to their functionality and responsibilities, that are data management, data access, data processing and data storage. Let us look each one of the component one by one. So two major components of Hadoop are HDFS and MapReduce. HDFS is responsible for the storage of the big data and the MapReduce is for processing of the big data. HDFS is nothing but the Hadoop distributed file system is designed to reliably store very large files across the machines which are distributed in a large cluster. It is inspired by Google file system. Distribute the large data file into the blocks. Blocks are managed by different nodes in a cluster. Each block is replicated on multiple nodes. Name node store the metadata information about the files and blocks. HDFS has two core components, that is name node and data node. The name node is the main node. It is a master node and it does not store actual data. It contains metadata, just like log file or the table of content. Therefore, it requires less storage and it has high computational resources then. On the other hand, the data node is storing all your data. Hence, it requires more storage resources. These data nodes are nothing but the commodity hardware like your laptop or desktop in a distributed environment. That's the reason why Hadoop solutions are very cost effective. You can always communicate to the name node while writing the data, and then it internally sends a request to the client to store and replicate the data on various data nodes. Here is the diagram of HDFS where name node is acting like a master and data node are the slaves. Another component of Hadoop ecosystem is MapReduce. It has two major parts, the mapper and reducer. Each block is processed in isolation by the map task called the mapper, and map task run on the node where the block is stored. The reducer consolidate results from the different mapper and produce the final output. So in a MapReduce program, there are two functions, map and reduce. The map function perform actions like filtering, grouping and storing of data. Sorting of data, while the reduce function aggregates and summarizes the result produced by the map function. The result generated by the map function is in the form of key value pair, which act as input for the reduce function. Now, what makes the Hadoop as a unique system? Moving computation to the data instead of moving data to the computation. In the Hadoop system, data is replicated at the different nodes. and we are moving the computation part to the data wherever it is stored. It has a simplified programming model that allow user to quickly write and test. And there is automatic distribution of data and work across the machines. Other Hadoop components in the ecosystem are HBase, that is Hadoop database for random read and write access, Hive, SQL-like queries and tables on the large dataset, Pig, that is data flow language and the compiler, Uzi, workflow for interdependent Hadoop jobs, Scoop, integration of database and data warehouse with Hadoop, Flume, configurable streaming data collection, and Zookeeper, which will coordination of services on the distributed application. Now let's cover the HBase. HBase is an open source non-relational distributed database. In other words, it is a NoSQL database. It supports all types of data, and that is why it is capable of handling anything and everything inside the Hadoop ecosystem. It is modeled after Google's Big Table, which is a distributed storage system designed to cope up with the large data set. The HBase was designed to run on the top of HDFS, and it provides big table-like capabilities. It gives us fault-tolerant way of storing the sparse data, which is common in most of the big data use cases. The HBase is written in Java, whereas the HBase application can be written in REST, Avro, and Thrift APIs. Now, when to use HBase? When there is a real big data, that is like millions or billions of rows, or in other way you can say data cannot be stored on a single node, then there is an use of HBase. When random read and access to the big data is required. When it requires to do thousands of operations on the big data. When there is no need of extra features like RDBMS having like type column, secondary indexes, transactions, and advanced query language. When there is an enough hardware, then we can go for the HBase. Now here is the difference between HBase and HDFS. HDFS is good for storing the large files, while HBase built on the top of HDFS, and it is good for hosting very large tables like billions of rows or millions of columns. In HDFS, you can write once, append to the files in some of the recent version, but it is not commonly used. In HBase, read and write many times. In HDFS, no random read and write, while in HBase, random read and write are possible. In HDFS, no individual records look up, rather it will read all the data, and in HBase, fast records lookup can be possible. So these are the references. Thank you.